termodinamika. You can call me Aprida.
With the air, like I don't care, baby, by the way. Because I'm happy.
Hi guys, my name is Gafrian Sarabani and you can call me Anca.
Hello, I am Ali Afi. You can call me Aal.
Hello guys!
We are from Group
Hi! And we will explain about
Steam Turbine. Do you want to know about steam turbine? And do you want to know how about the mechanism?
and what the connection about steam turbine and thermodynamics?
So enjoy this video.
Well, give me all you got.
Definition of steam turbine. Do you know steam turbine? Yup. Well, the steam turbine is a machine that converts steam energy into the kinetic energy by expansion through the nozzle. And the kinetic energy generated by burst of steam which is converted of working down the blade found on rotating part. So we can conclude that the steam turbine is a heat, pressure, and motion. Under pressure steam is used to drive the turbine well back through the blade. Then the steam turbine is divided into two, namely impulse turbine and traction turbine. 1. Impulse turbine, also a turbine or constant pressure turbine, where the steam is expanded only on the nozzle run, so the power pressure before and after the blade is constant. 2. Traction turbine or chain pressure turbine, where the steam is expanded both inside the nozzle and through the turbine blade, so that the power pressure after the exit of each level is lower than the previous blade.
Clap along if you know.
Principle of the steam turbine is rankine cycle. Water is pumped in the cycle and get into the boiler with a pressure equal to pressure in the condenser, and then get into boiler turbine with a superheated condition. When under pressure and at high temperatures, steam has thermodynamic potential energy called enthalpy. For example, in a pressure cooker, when the steam reaches a certain level of pressure, it spins the stopper and begins to heat. When the steam has been heated, it stores energy, as well as the capacity to expand and occupy a greater volume. While the pressure cooker is closed, the steam's energy cannot be released. But when the valve opens, it expands into the ambient air and releases part of its potential. It is energy that turns the stopper. By channeling this force, we can drive pistons or turn wheels. Alstom applies the same principle to its turbines. The steam is controlled to rotate the turbine by transmitting a mechanical force to them, with as little energy loss as possible. The hot pressurized steam arrives in the turbine. It is drawn through to the other end and thanks to a cold source. Between the intake and the exhaust, the steam expands. It seeks to occupy a greater volume. To recover the steam's potential energy, it is led through a series of blades which include fixed blades attached to the body of the turbine and mobile blades attached to the rotor. As the steam passes through the fixed blade, its passage is narrow to increase its speed. Its speed like a river. When it's narrow, the speed of the water flow increases. It's what we call rapid. Hence, a narrower passage through the fixed blade speeds up the flow of the expanding steam. Thus, a part of its enthalpy is converted into kinetic energy. The steam is directed by the fixed blade toward the mobile blade, which it flows across. These mobile blades are curved to change the direction of the expanding steam. By doing so, the mobile blades are pushing back and begin to move. As these blades are fixed to the rotor, they drive it. Hence, the kinetic energy of the steam is converted into mechanical energy. This mechanical power is gathered by the turbine rotor and transmitted to the generator, which converts it into electrical power. The steam passes via successive rows of fixed and mobile blades. As it moves through the turbine, the steam occupies increasingly more volume. This means that the size of the successive blades gradually increase, so as to maximize the conversion of the steam's energy. When steam emerges from the last series of mobile blades, it is recuperated through a condenser and recycled in the form of water towards the steam generator. Then the cycle begins all over again.
Ranking cycle is a thermodynamic cycle that converts heat into working heat. There are 4 processes in the Rankine cycle.
Process 1 until 2 is isentropic compression via centrifugal pump. The saturated vapor expands through a turbine generating electricity. This lowers the temperature and vapor pressure, and some condensation may occur. Process 2 until 3 is isobaric heat transfer via steam generator. Wet vapor then enters a condenser where the condenses at a constant pressure to become saturated liquid. Process 3 until 4 isentropic expansion of steam, energy extracted via turbine generator. The working fluid is pumped from low to high pressure. As the fluid is a liquid, at this stage the pump requires little energy input. Process 4 until 1 is isobaric heat rejection via condenser. High pressure liquid enters a boiler which is heated at constant pressure by an external heat surge to become a dry saturated vapor.
Myself believe that planet Earth turns slowly. It's hard to say that I'd rather stay awake when I'm asleep, 'cause everything is never as it seems. When I fall asleep, leave my door open just a crack.
How about this video, guys?
And finally, you know all about the steam turbine.
Yeah, thanks for watching this video and
Bye-bye!
Counting sheep, please take me away from here. When I'm far too tired to fall asleep. To 10 million fireflies, I'm awake.
Hello, guys!
We are from group 5.
How about this video, guys?
Ayo,
Hi!